So let's begin with number 1. We're going to simplify 12m to 14m. So first of all, we find the highest common factor of both numbers, which is 2. Then we divide both numbers by 2. So 2 goes 6 times into 12m, and 2 goes 7 times into 14m. So our final answer will be 6m to 7m. To simplify this expression, I collect the like terms. So 4x minus 2x is 2x. 6y plus 3y is going to be 9y. To simplify this rate, we find the highest common factor, which is 5. Then we divide both numbers by 5. So 5 goes into 5 once, so that's 1 telephone. 10 divided by 5 gives you 2, so it's going to be per 2 employees. So now we're going to solve a simultaneous equation. So what I always do is I first label them, equation 1 and equation 2. Then to solve this, we have to make sure that at least one of the coefficients are equal. So what I can do is I can multiply equation number 1 by 3. So 3 times 2x will give me 6x. 3 times negative 3y will give me negative 9y. And 3 times 10 will give me 30. So here we have our new first equation. So put them together. And what you can do now is you can take away equation number 2 from equation number 1. So 6x minus 6x gives you 0. Minus 9y minus 10y will give you negative 19y. 30 minus 30 will give you 0. Let's try and solve for y. So negative 19y equals 0. We can take the negative 19 to the other side and divide. So 0 divided by negative 19 will give you 0. So y equals 0. Now let's try and find our x value. So what we can do is we can substitute the y value back into one of the original equations. Since we know that y equals 0, we can substitute y equals 0 into the equation. So 2x minus 3 times 0 equals 10. So 2x minus 3 times 0. 3 times 0 will be 0. Then we can take the 2 to the other side and divide the 10. So 10 divided by 2 gives us 5. So our final answer is y equals 0, x equals 5. Or if you need the coordinate form, it will be 5 to 0. Now let's try and solve this quadratic equation using the quadratic formula. So a, in this case, will be equal to 3, b will be negative 7, and c will be equal to 2. Now let's write out the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Let's substitute a, b, and c into the equation. So negative b, which is negative times negative 7, plus or minus b squared, which is going to be negative 7 squared, minus 4ac. So this is going to be 4 times 3 times 2 divided by 2a, which is 2 times 3. Now let's simplify this. So negative times negative 7 will give you positive 7, plus or minus the square root of negative 7 squared is 49, minus 4 times 3 times 2 is 24, divided by 2 and 3 gives 6. We can simplify further the numbers under the square root. So 49 minus 24 is 25. So now we can rewrite this again. 7 plus or minus the square root of 25 will be 5 over 6. A quadratic equation will have two solutions. So to find the first solution, we can use the plus sign. So it'll be 7 plus 5 over 6, which is 12 over 6, which gives us our first answer, which is 2. The second solution, we will use the minus sign. So 7 minus 5 over 6, 2 over 6, which simplifies to 1 over 3. So here are our two solutions. For this question here, what I like to do is I like to convert from the Sydney time to the Tonga time. So as it says, Tonga is 3 hours ahead of Sydney. So the way to convert this is to add 3 hours to the Sydney time. By adding 3 hours to the Sydney time, we will get the Tonga time. So 11:20 plus 3 hours, that should get us to 2:20 a.m. So 2:20 a.m. on a Wednesday morning. And the time that we arrive at Tonga is 10 past 7 a.m. on Wednesday. Now we can find the duration of the flight by finding the amount of time between 20 past 2 a.m. and 10 past 7 a.m. So now we have the time between 2:20 a.m. and 7:10 a.m., which is 4 hours and 50 minutes, which is the duration of the flight. Now let's try and find the total order of symmetry of a rectangle. Remember that the total order of symmetry is equal to the lines of symmetry plus the rotational symmetry. So let's begin by finding the lines of symmetry. Now a rectangle has two lines of symmetry, as shown by the two lines that I've drawn, which means that if you were to draw these two lines, what you would see on one side looks exactly the same as what you see on the other side. Now let's work out the rotational symmetry. If you were to rotate a rectangle by 180 degrees, what you will get is the exact same shape. If you were to take, once again, the starting shape and rotate it by 360 degrees, what you get is the exact same shape. So therefore, the rotational symmetry of a rectangle is 2. So therefore, the total order is equal to the lines of symmetry, which is 2, plus the rotational symmetry, which is 2. 2 plus 2 gives you 4. Now we have an inequation and we have to solve for x. So the first step would be to multiply and expand the bracket. So 2 times 1 is 2. 2 times negative 4x is negative 8x, less than negative 14. We can take the 2 to the other side and subtract from the negative 14. So we are left with negative 8x is less than negative 16. Now we can divide the negative 8 through to the other side. And remember, when dividing by a negative number, the inequality will change. So this will go from less than to greater than. Negative 16 divided by negative 8 will give you 2. So x is greater than 2. Now we have two algebraic fractions which are equal to each other. So what we can do is cross multiply. So 5 multiplied by x plus 1 and 2 multiply x. Now we can expand the left hand side. 5 times x is 5x. 5 times 1 is 5 equals 2x. Now we can take the 2x to the left hand side so that we can collect the like terms. So 5x minus 2x equals negative 5. So we've taken the 5 from the left to the right and it becomes a negative. 5x minus 2x gives you 3x equals negative 5. Then we can divide by 3 to get x equals negative 5 over 3. Now we're going to find the period of the sine curve. Now if you remember how to plot the sine curve always begins at 0, then it goes up all the way to 1, goes down all the way to negative 1, and then goes back up to the x-axis. So the first x-intercept is at 0, the second x-intercept is at 180 degrees, and then the third x-intercept is at 360 degrees. As we can see, the period, which is one complete revolution, is 360 degrees. Here we are trying to find the y-intercept. So remember, at the y-intercept, x is equal to 0. So what we can do is we substitute x equals 0 into x minus 2y equals 4. So if you do the substitution, what you will get is y equals negative 2. Now for the final question. This one is very similar to the one we've done before. So the first step is we're going to change the Auckland time into Tonga time. So we have the New Auckland time as 16:45. We can change this to the Tonga time by adding 1 hour. So 16:45 plus 1 hour we will get 17:45. So the Tonga time of arrival is 17:45. We are told that the flight was 3 hours. So we can find the departure time by taking 3 hours away from 17:45. So moving backwards from 17:45, we will get to 14:45 Tonga time. So the time of departure from Tonga is 14:45 Tonga time.